Hello, my name is Trevor Masias.
And my name is Tristian Gonzales.
I'm Luke Treadway.
Hello, my name is Tristan.
I'm here with the Blue Collar Boudoir, team number 1. I'm going to present to you the Roadside Emergency Service Swarm. Roadside emergencies place motorists and roadside assistance personnel in dangerous situations, particularly on busy highways and in low visibility conditions.
Our system is designed for anyone responsible for handling roadside breakdowns. This includes everyday drivers, roadside assistance teams, highway patrol, and transportation agencies, as well as organizations that manage large vehicle fleets. Current roadside response can be slow because responders often do not know what equipment or repair is needed until they reach the vehicle. Drivers and workers may also spend extended time near moving traffic while waiting, inspecting the problem, or placing warning equipment. And poor coordination and limited information can therefore increase response time, cost, and exposure to dangerous conditions. Our swarm turns roadside response into a coordinated sequence rather than relying on one worker or one general purpose machine. The system first secures the scene, then diagnoses the vehicle, and finally deploys the robot and equipment best suited for the problem. This improves decision making, reduces unnecessary delays, and limits how long people must remain near traffic. Our system includes 4 robots, each designed for a specialized role. The autonomous delivery vehicle transports and coordinates the swarm. The safety zone robot protects the scene and the people within it. And the tire and lift assistance robot provides lifting and tire service equipment. And the diagnostic scanner robot identifies the likely vehicle problem. Together, these 4 units operate as one connected roadside response system to increase safety for everyone involved.
All right, so to get into more detail about our robot swarm here, we'll first look at our autonomous delivery vehicle, who acts as a home base from which 3 other robots receive signals to deploy and return. Your inputs here include a photoelectric resistor and 3 switches that initiate swarm activation, ramp deployment, and several lights. Your outputs, you're looking at hazard and work lights and a servo motor that controls the ramp deployment. Then moving on to a safety zone robot, who establishes a safe zone by dispensing flares around the disabled vehicle. Your inputs include an ultrasonic distance sensor, who controls a collection actuator, a servo motor to dispense/collect flares, and a dispenser actuator. Then moving on to our diagnostic scanner robot, who diagnoses issues with the vehicle and performs an initial vehicle assessment. Your inputs include an ultrasonic distance sensor, potentiometers, temperature sensor, and then your outputs include 2 DC motors for navigation, a servo motor that controls a diagnostic OBD compartment, lights, and a warning buzzer. And then lastly, you have your tire and lift assistance robot, who assists with lifting a disabled vehicle for repair needs. Your inputs include an ultrasonic distance sensor for navigation, a force sensor, a push button, and then your outputs include 2 DC motors for motion and a servo motor to control the lift arm.
Once the ADV arrives on scene, the safety zone robot will deploy its 6 flare beacons at 100-foot intervals and then park itself. The diagnostic scanner robot will make its way to the vehicle, and the driver will be able to take a wireless plug from it to plug into the vehicle. As the diagnostic scanning robot is making its exterior view around the vehicle, it will download the data from the plug. Once all of that is done, it will let the driver know if the situation is a situation that we can assist with, or if it will need professional assistance. And it can also determine if there's a critical or unsafe condition that will require towing. Once that's done, it will return to the ADV. If it's a situation that requires a tire changing, the TALA robot will make its way to the vehicle and use the information from the diagnostic scanning robot to know where to lift from properly on the vehicle. With the help of roadside assistance personnel or the driver, a tire can then be changed. Once done, the TALA robot will return to the ADV. And once everybody is back in a safe condition and the robots are back inside the ADV, the safety zone robot will recollect all the flares and return back to the ADV. One competitor we believe that we would have would be OnStar. A way that we believe that we could add value over what they offer is our automated robots. They could improve safety by keeping the drivers and the roadside assistance personnel out of harm's way as much as possible. We also believe that through the use of our ADV, we'll be able to supply common medical supplies or tools and parts to help assist in the situation. In closing, we at Blue Collar Boudoir believe that this project has helped us see the need for improved safety for roadside issues and how automation could be one possible solution. Even if the whole process is not automated, any one of our robot ideas can decrease the risk imposed upon a driver or roadside assistance personnel. We thank you for your time and consideration.